I am Sami Hyytiäinen. I am from Advenica. I'm the country manager at Advenica, and I'm here to talk something about how you can securely connect air gap systems to a cloud. So let's dig into it. Couple of words from Advenica. So Advenica is founded in '93, and we were first concentrating on high-level encryptors and mostly government defense encryptors. And when the kind of business expanded, we expanded our product portfolio also to cross-domain solutions. And that was in 2010, starting and at the same time we became kind of experts in cybersecurity solutions. So we also did more than just providing solutions. We also did consultancy integration to customers, and then we also entered to critical infrastructure, so which is now our other main focus, in addition to governmental sector customers. We do all our own products ourselves. We use third parties. Like here, there's Process, one of our partners. But all the products we do ourselves. We design them, we develop them, we produce them. We install them, we maintain them usually, or through our partners. We have offices in Helsinki, where me and our team here is from. Then we have offices also in Malmö, Stockholm, and Vienna. And where our customers are located, so we're in key positions. And we're overall some 100 people working, where mostly is R&D people. So gives you kind of an idea where our focus is. Okay. So if you talk about cloud, I guess there is no presentation where somewhat the security would come into play. And if there is a presentation that doesn't talk about security when you talk about the cloud, I would say then change to the next presentation. But of course, I come from a security company, so I have my own view on it. But some of the basic benefits, which I think you all are somewhat familiar, is that it's flexible. You can virtualize whatever, so it's a virtualized environment. It's cost effective. I think that's the main driver for most, that you can get reliable backup and recovery, cheap storage, and especially in the case that I will show you in the next slide is that there is unbeaten analytics services, which also operational technology companies are interested in using. And of course, the business benefit is just it's cheaper. So you don't have to own your infrastructure. You can kind of lease it. And there are services running which you can use that someone else maintains them and updates them. But of course, there are concerns. And mostly what I'm focusing on are the security concerns. And that is that whatever is in the cloud is exposed to unlimited, like you say, attack vector space. So you're exposing your data, and I will show this in the coming slides, but of course you're also exposing all the connected environments. So whatever you are connecting to the cloud is also in some level exposed to the all of the internet, so internet connected world. And of course the concern in these cases in operational environments is that sometimes, or if I dare to say many times, they're legacy systems. So when we see customer environments, when we work there, they are more or less legacy systems, with some exceptions, of course. And most of all, underlining all of these is the business continuity. So everybody wants to have a good business continuity, which is based on the, analyzed risk level and so that it's approved and it's known and you can live with it and have a good night's sleep knowing that, things are in balance. Yes. So the use case I'm here talking about is electricity production company with multiple sites, and their goal is to have a secure way of having monitoring data available in the cloud, and also to be able to utilize the vast and advanced capabilities of the cloud for analytics. So to be able to monitor their systems in a cloud and then utilize analytics. And when we evaluated with them the concerns, their concerns, these are the main ones. So how to manage the risk to open up the air gap, and it's not easy, especially in regards of legacy systems or legacy environments. And also, what does it cost if you develop or scale the environment up so that it's not that legacy anymore, or it's legacy but it's updated and patched and hardened so that it actually can handle whatever is coming from the internet connected world. And there is a cost, and how much is it and to what level you need to be in an acceptable risk level, that's the question. And then how you export the data uniformly, because you can have multiple sites and there can be different kind of systems, control systems, whatever, that communicate with different kind of protocols or even message types and whatever. So you need to have a uniform way. And in this case, it's of course OPC UA in this context, which we use. And then how to do the transfer securely, and then also how to ensure the business continuity. So those were the main concerns. So looking at the starting point. So simple picture, nothing to do with the actual servers, actual systems, all from the network perspective, the segmentation perspective. So multiple sites, you want to export something from those sites to a different segment. And let's say the segment in the center is kind of where things are, where data is collected and where the data is analyzed and monitored. And there, in this case, was a firewall. So maintained on-premise firewall. And firewalls are great. They are great multi-purpose machines, but they are also complex. And when you have a complex system, you need people to maintain it, and people make errors. So there is always the possibility that you open up something that you weren't supposed to, and then you're opening something that is kind of, or not kind of, but is an access to your environment. And yes, firewalls are hardware products, but they are rarely pure hardware products. They are partly software or even completely software products. And that's when you introduce vulnerabilities. Okay, you can patch them, but it's not that easy always, or even possible, without interrupting the production. Or it's even so that there are these advanced persistent threats that, 0 days and whatever, that you can't do anything about other than close those ports, services, whatever, and then the production hurts. And then in this case, the need was to put something to the cloud, export data, which was actually, like I say, phase one, already existing, and that was done with the firewalls. So, and as it is that you're now bringing in the cloud integration, you are even more expanding the exposure of your technological or operational technology environments. So this is kind of the part where we introduce to them data diodes, as you can see in the picture. So what is a data diode? It's a physical one-way security appliance. It's kind of an advanced firewall, but it's not. So its purpose is not to kind of limit who can send the information. It's to limit that you can only transfer data one direction and one direction only. So there is no physical means to send information back. And this is what I mean by saying that this is the way to securely export data to wherever from an air-gapped system. So to be able to send something back, you need to go physically to the device, open it up, and do some wiring and hooking up, and even touch the software maybe to be able to get something flowing through. So it's kind of impossible. And there is zero chance of doing that remotely. So you need to have access. And that was also the will of the customer. So it was kind of easy case because the customer had already made homework and had an idea that we need to do this with data diodes. And we did that with OPC UA because that's standardized means for us to pass through traffic. And in this case and in many others, we first standardized the traffic in a uniform format, which is OPC UA, and we pass it through. And in this case, they wanted to have analytics, as I said, so they could do that and also then analyze and monitor that data also remotely. So they could get access and remotely to the cloud and without having the worry that the actual operational environment would be somehow affected. So whatever happens in the cloud doesn't affect their on-premise systems. So why am I putting here still firewalls? The reason is that this is not a replacement for firewalls. It's an additional layer of protection. So we recommend and you still need those firewalls to actually limit what can be sent and by whom and to where. Data diode is just in this case the one-way passage device. So there is a place for both if you do a secure implementation. So to keep it short and to have time for the demo, some conclusions on the use case is that yes, cloud services can be used securely without increasing the OT environment exposure. And in many cases, you can even considerably decrease the exposure by implementing to existing systems. And in many, although these solutions have a price, but if you compare it to price of updating and patching and hardening your operational environments, it's peanuts. So it's in some cases like interconnecting legacy systems, networks, even the domains, it's the only viable solution. And in those, the OPC UA is the selection for us to pass that information through and export it. And why we use OPC UA is that it's in our minds and from our view, the most secure protocol to do that. So it provides you the security means that we're looking for, and also in a basic form like encryption. And you can also use advanced methods like certificates to authenticate the source and the destination if you want. Yes. So then there is Magnus, and Magnus will show you a short demo on how this actually works. So maybe I can directly give the word to you.
Yeah, so short demo indeed. So hello, my name is Magnus Kullström. I'm a lead solutions engineer at Advenica. And for this case, we have built a short demo how to use the OPC UA over a diode. So what we have done basically is we have implemented the OPC UA protocol for our diode. In order to get anything through the diode, you would need to understand the protocol itself. So we have, for example, two different levels of diodes. So level 2 diode, which is considered kind of a dumb diode. So you just need to pass just almost anything UDP through it. And then there's the level 3 diode, which can understand different protocols and which also needs the protocols to be implemented. So in this case, we have implemented the OPC UA with the help of Process with their solutions. So there might be some product placement in this demo present. So what you are seeing at the moment is the Process OPC UA monitor, which resides in Azure cloud, and it's connected to a Wirecard VPN. So our demo set is currently at our booth over there. So if you want to take a look at the other side, the local side, so the OT environment as well, so you're welcome to come over there and take a look. But basically, we are sending the OPC UA simulation server data over the data diode by using an OPC UA client locally on the data diode, which reads the OPC UA simulation server values and passes those through the hardware part of the data diode, which is basically an optical one-way link, which are kind of these serialized data packets sent over the other side. The diode has kind of two proxies on both sides, so one on the downstream and one on the upstream, and the upstream side proxy then gets those data packets and rebuilds the protocols to resemble OCP UA and sends it to the monitor over the VPN link to the cloud side. So thusly, basically having the OPC UA to the cloud being pushed there. As said, it's a kind of a simple demo, but demonstrates the use case that you can basically send telemetry data securely without breaking the air gap into the cloud environments. Yeah. So our demo set is over there. So if you have anything else, I think we are open for questions.
So any other OPC UA data to pass through the cloud, just bring it there.
Yeah.
Thank you.
Yeah, thank you.